And welcome everybody to the Daily Space Weather. We've got a coronal mass ejection warning today, solar composite imagery, and lots more to cover. Let's get right to it. First thing we're looking at here is sunspot 2833 in colorized magnetogram from the Solar Dynamics Observatory. To see it's remained relatively stable, but it's grown some additional umbrae since yesterday, so the likelihood of significant solar flares produced by this sunspot has gone up. So at the same time, we see a coronal mass ejection warning, which we'll get to in a moment. In place, we see a complexity build for sunspot 2833. As the more complex the magnetic fields get, the more likely it is to produce significant solar flares. Here's a full disk view in 171 angstroms, also from the Solar Dynamics Observatory. And we'll get to some composite imagery momentarily here. First, a close-up of the northern hemisphere in that same wavelength, where all the action's been going on the past week or so in the north of the solar equator. Here's 304 angstroms, which is ionized helium, by the way. 171 angstroms is ionized iron. And you can see some of the filaments, such as this one up here, which, let me actually draw that in. So this filament up here is sort of shaped like this, and one end of it appears to be anchored just to the south of sunspot 2833. Great view of that filament there. You can kind of see it. And that is probably, don't quote me on it, that's probably the filament that's going to eject. Again, coronal mass ejection warning. Here's a composite of these two wavelengths. So it's 171 and 304 angstroms combined. And you can make these composite images yourself on helioviewer.org. It's quite a bit of work, but it's worth it for the spectacular imagery. So let's take a look at the viewpoint from stereo A here at Lagrangian point 5, where Earth would be off to your right, to see a massive plume. A massive, massive plume of plasma right out here. And that's the source of the coronal mass ejection warning. Let's continue on. Here's where stuff's located in the solar system. There's where things will be in 1 week. And by the way, spring ends today. More on that later in the video. If you're up before dawn, you may see Mercury rising ahead of the sun. And you may also see Jupiter and Saturn up there near the ecliptic, which is this yellow line we've drawn in. It's the path the sun takes across the sky. This is from in-the-sky.org if you'd like to make your own star chart. The 10.7 centimeter radio flux, which is the most proportional aspect of solar activity pertaining to sunspot number. It's proportional to sunspot number, and it's emanated from the upper chromosphere and the lower corona. It's at 77 solar flux units. Here's the 1-year chart of that. The black line is the radio flux, the red line is the sunspot number, and you can see how proportional they indeed are. And we're not seeing any warnings here from NOAA. On the Space Weather Enthusiast dashboard, you can see all geomagnetic calm conditions forecasted for the kickoff to summer, which, by the way, starts tonight at 11:32 and 10 seconds. Next, looking at seismicity here, and I would like to note the 7 magnitude earthquake drought that we've been seeing here. So despite one 7 magnitude earthquake here in the past 45 days, that's the year-to-date chart from volcanodiscovery.com, which has all sorts of tools to organize earthquakes. Here's the 90-day chart, and you can see in the past 90 days a real drought of 7 magnitude earthquakes, and often droughts of water go hand in hand with earthquakes. And since we're seeing major droughts on the west coast of the U.S., I'll just leave it there. So we have seen some 5+ magnitude quakes, including a 5.8, I guess downgraded to a 5.7 in the Kermadec Trench region there, northeast of New Zealand. And let's take a look at the list on USGS. So let's see. We saw a 5.8 magnitude quake here at Fiji just before noon Universal Time yesterday. That appears to be the largest quake of the past 24 hours. Let's scroll up the list here. Also a deep quake to the east of that 5.7. Also a deep 5.4 in Central America there. Actually, southern Mexico, technically. Also, Indonesia saw a 5.2. The Band AC saw a deep quake at 4.7 magnitude and 156 kilometers depth. The Philippines saw a deep quake. Argentina saw a deep quake. Chile saw a deep quake. So again, folks, if you're in an earthquake-prone zone, please have a plan. I mean, 7 magnitude earthquake droughts end in large earthquakes. Know which building facades may collapse if you intend to evacuate yours if things start shaking big time. Know which building facades may collapse. The oldest buildings tend to be built with the least care. And let's talk about pole vaulting calderae. Please don't pole vault volcanic calderae, folks. We need the views on YouTube, and we prefer for our viewers to be in good health, so please don't attempt to pole vault the caldera a la Steve Stimpak. This public service message brought to you at massive personal risk and expense. From smAshomash.com, and let's see what volcanoes have been erupting. Etna remains on the list. It's been emitting volcanic ash. No idea of how high of an ash plume that is. Please don't hang glide over the caldera. Suwanosejima, flight level 040, a 4,000-foot ash plume produced there as it exploded. Semeru on East Java, Indonesia. Volcanic ash moving north from Semeru, Revenador. No volcanic ash clouds observed. In Ecuador, Sabancaya exploding, producing a 24,000-foot ash plume over Peru, and we're unable to detect Nevados de Chilean. Again, please do not pole vault the caldera. It could be unfortunate. Next, going back to solar data here. The GOES-16 reporting no significant solar flares here. That's the 3-day chart of the X-ray flux. When we talk about solar flares, we're talking about photons. When we're talking about coronal mass ejections, we're talking about protons. And we may see a spike in here as we have, again, I'll repeat myself, forecasted a coronal mass ejection. There's a coronal mass ejection warning in effect, and that could absolutely affect the proton flux. And the GOES magnetometer has been fairly smooth here over the past 3 days. Expect some extreme moves in this, and I'll show you why on the next slide. So looking at the Gong2 data here, it's the top view ecliptic plane field plot. This data is gathered from 51 ground-based magnetometers, as well as magnetometers on stereo A and stereo B. And you can see these areas right here, very straight potential field surface source lines leading all the way to the solar corona. So these areas behind this suspended plasma will indeed show us higher readings on the GOES magnetometer. Anyway, here's another view of the same data, the line of sight ecliptic plane field plot. It also shows you the solar magnetogram, and that blue line gives insight into the BTBZ, for example. The BZ component can be translated into this blue line here. North Pole oriented current sheet is currently the one in which Earth lies. Keep in mind the magnetic environment can change suddenly with no warning, and the data was nearly 2 hours old when we made the video. Next, the line of sight coronal hole plot. It shows you the sun's B field in blue, and you can see some changes happening as the sun's solar polar field progression is a thing that's happening. This trans-equatorial North Pole-oriented coronal hole affecting the sun's B field. That's all I'll say, as cycle 25 is taking its good old time to progress. Next, looking at detected sunspot groups and coronal holes. Really, this coronal hole up here actually does extend all the way down to here. And you can see sunspot 2833 has been designated a beta-gamma class sunspot. Again, the likelihood of solar flares has gone up. The likelihood of coronal mass ejection, just about 100%. Global geomagnetism currently only at a KP of 1. Global geomagnetic calm conditions, the KP index, a measurement of global geomagnetism. Next, we'll take a look at the real-time solar wind. Fairly uneventful here over the past 24, although over the past about 15 hours, we've seen it slightly ramping up in terms of solar wind density and some shifts in the phi angle as well. Fairly uneventful, though. Current solar wind density 6.84 protons per cubic centimeter. Solar wind speed 430 kilometers per second. Fairly basic. And next, looking at magnetohydrodynamic pressure of the geospace. It's a geospace magnetosphere movie courtesy of University of Michigan. It's 4 hours of data showing magnetohydrodynamic pressure in nanopascals. We may see a slight ramp up here. I doubt it. It's not going to show you very much of a pressure increase with that minor increase in solar wind density. I'll let it play through again a second time since it refreshed, and we don't want to edit the videos to get them released as quickly as possible, as the data is quite timely indeed. And most of the data that we show you should look at the time and date stamps, as they're not always in the same time frame. Again, this one's only 4 hours of data. Next, we'll look at ground magnetic perturbations here. Geospace delta B would be changes to the Earth's B field, and now we're looking at actual magnetic flux density in nanotesla as opposed to magnetohydrodynamic pressure. And you're looking at surface changes to the Earth's own B field. Fairly minor perturbations here with a fairly consistent solar wind speed. Now, we do regularly stream live to Twitch, and we're actually going to do it right now. So join me in welcoming our Twitch viewers for this extremely short Twitch video. There's a coronal mass ejection warning in effect, and you may want to subscribe to our channel on YouTube, youtube.com/smAsho, as today we will not be making a substantive video on Twitch except to advertise the fact that most of our content is located at YouTube. So here ends today's Twitch live stream. Thanks for tuning in. Again, youtube.com/smAsho for most of our content. Today we'll have a meteorology segment that will also be recorded and uploaded to YouTube, however, not visible on Twitch. So see you next time, Twitch. We'll probably stream live tomorrow, and indeed tonight. Continuing on with the daily space weather. Thanks to our YouTube viewers. Please don't forget to press like and subscribe. If you enjoy the content, tell your friends and foes about the channel. Press that share button and press the notification bell so you're informed when we make videos. Thanks again, YouTube subscribers. Cheers. We're also on BitChute. And today's cosmology segment will actually be integrated into the daily space weather video. Let's do it. First, the astronomy picture of the day, which is located at apod.nasa.gov. It's a picture of the sunrise over Stonehenge on the day of the solstice. So in the northern hemisphere, the solstice is the day that the sun reaches its highest point on the ecliptic for the northern hemisphere, or the lowest point on the ecliptic for the southern hemisphere. And it's the day on which the days start getting shorter. So when summer begins, folks, the days begin getting shorter in the northern hemisphere and longer in the southern hemisphere on the June solstice. Anyway, there you go. Astronomy picture of the day, apod.nasa.gov. Sunrise solstice over Stonehenge. We've picked a random number today, and it's 67, which coincides with this blazar, 4C15.05, and it's looking very dim here in infrared, indicating it's probably very distant, as blazars tend to be quite bright. This one's probably located at billions of light years distance. Anyway, that's the 2-mass imagery, which is infrared light. Here it is on the pan-stars, which is optical bands. I doubt it's going to show up on hydrogen alpha. And it's also not on the Chandra, surprisingly. Does it show up in blue light? It actually looks like a dark spot. And the interesting thing about blazars, folks, is perspective. So when it comes to blazars, what makes blazars special is perspective. So if we were viewing this particular galaxy here from this perspective, this would appear to be a Seyfert 2 galaxy or something like that, an active galactic nucleus, but not a blazar, as you would have to be viewing the blazar from this sort of a location, within the poloidal jet, which emanates from galactic cores. The massive radio sources located at the cores of galaxies have a tendency to produce these jets. And if you're inside the jet, it looks like a blazar. Now, blazars used to be believed to be just oddball stars, but it turns out they're actually active galactic nuclei, the most active galactic nuclei, and they're sending a particle beam and all kinds of additional radiation through that poloidal field directly toward you, the viewer. So this particular blazar, also known as quasar B0202+149, emits X-rays which are detectable here at Earth, and there are the X-ray transient outputs from it. The past 16 years shown up here in the upper right, the past 30 days in the lower left, and the daily, which is showing like 2 days in the upper left. And again, that's today's random number. It's 67, which coincides with entry 67 at the Neil Gorell's Swift Burst Alert Telescope, which monitors X-ray sources. By the way, we are also counting down to the solstice. We've only got hardly 12 hours here. Let me refresh. Only 17 hours and 9 minutes until the solstice when we make the video. We will be streaming live at the moment of the solstice. We want to be the first channel to wish you a happy summer or happy winter if you're in the southern hemisphere. That occurs at 11:32 and 9 seconds tonight. That's Eastern Daylight Time. We'll be streaming live probably about a half hour before and after the moment of the solstice. That's today's cosmology segment integrated into today's daily space weather video. And if you haven't seen previous cosmology segments, check them out. youtube.com/smashamash/playlists contains all kinds of information you may not know if you're only viewing the daily space weather. Next, looking at electron flux, and we've seen an ongoing electron storm here as we've reached electron flux warning levels for the past few days, and we're seeing a result of that in charging hazards. So most of those, in fact all of the charging hazards shown here, are south of the equator. Places like Oceania, the southern Indian Ocean, the southern Atlantic Ocean, southern Africa, and the southern Pacific Ocean, all seeing some charging hazards. It could cause things like CCD bakeouts, where charge-coupled devices on satellites shut themselves down to prevent themselves being damaged. Here's the one-year chart of the electron flux. Relativistic electrons surround planet Earth, and there's a one-year graph of them from Solon.info. And here's the 3-day chart, and it looks like we're seeing a little bit of a subsiding of the high levels of electron flux. This back here was about 5 times warning levels. Now we're at more like 3 times warning levels or something around those levels. Here's the forecast model, and NOAA forecasting similar levels tomorrow, so we could see additional charging hazards. Here's the total electron content forecast showing you electron density through the entire air column, and I mean the entire air column, all the way up to a GPS satellite and down to your handset. We'll let it play through. And you can actually verify this yourself if you're in one of these areas with high electron density overhead. Turn on your GPS without location accuracy service turned on, and you may find errors of thousands of miles. I've done bike rides with average speeds of over 10,000 miles per hour as a result of GPS errors and not having location accuracy turned on, which uses Wi-Fi signals to give you better accuracy data. Next, looking at the ionosphere, just one slice of the atmosphere, around 300 kilometers altitude. We've got vibrational frequencies kicking off. The ionosphere is largely the bridge between space and Earth. There's a lot of chemical reactions and all kinds of vibration happening up there. And once again, we're seeing significant ionospheric anomalies, mainly over Central South America and the South Pacific. So if you look right in this area right here, you'll see sudden charge up to the ionosphere here, where you're seeing these high vibrational frequencies happening. That's not really normal, as the sun is over the northern hemisphere, as we're just about at the northernmost point of the sun's path, which happens later tonight. Anyway, here's the latest image coming through at 10:15 Universal Time. Things looking a little more normal there. Don't be surprised to see them get weird, where we see a charged up ionosphere over this portion of the planet. We've documented it for days on the Daily Space Weather videos. And again, the F ionosphere layer is one slice at about 300 kilometers of altitude. We're also going to do a meteorology segment. It'll be a separate video today, so make sure you check that out if you haven't. And again, you can find all of our playlists at youtube.com/smashamash/playlists. We've got meteorology segment and cosmology segment playlists there, so check them out if you haven't done so. And it's time for bonus features here at Smash News Network, Lee's Busted Name It News. You can see some of these massive filaments we've talked about earlier, mostly in the northern hemisphere. Again, sunspot 2833 has gained in complexity. This is the latest hydrogen alpha imagery from El Teide, Spain's ground-based solar observatory, part of the National Sunspot Observatory. Coronal mass ejection warning in effect. So here's what we saw during show prep. Oh, actually, first, I stand corrected. It's the thematic map. And it's a great map from the GOES 16 SUVI, showing you all of the features. And you can see a whole bunch of filaments right between the Earth and the Sun, shown here in orange, all around sunspot 2833. And they are about to be released. So here's what we saw during show prep. You can see these additional umbrae. This one up here is a South Pole umbra. This one's a North Pole umbra. And that complexity is responsible for the likelihood of additional solar flares. So here you can see that's clearly a red South Pole-oriented umbra. And here's some more moving imagery of the closest star. This is 131 angstroms from the Solar Dynamics Observatory. Here's 94 angstroms. By the way, 131 and 94 angstroms are the highest temporal resolution that the SDO takes, 10 images per minute instead of only 2 images per minute. And we've got an amazing composite here to close out today's daily space weather video. This is 1700 angstroms and 335. Spectacular view here of sunspot 2833 and its increase in complexity over the past 24 hours. Thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, don't drink, and if you do, don't drive. I don't really care if you drink, just don't drive. And certainly don't drink and drive. Anyway, don't forget to check out our other videos. Don't forget to press like and subscribe if you enjoy the content. Don't forget to tell your friends and foes about the videos. Press share. Press the notification bell. We'll see you next time here at Smash News Network, Least Busted Name and News. And may that solar wind be at your back.